As we're pulling up Dr. Hernandez's presentation, I'd like to give a brief introduction. And again, we're very excited to have Dr. Laura here with us. Dr. Laura Hernandez is a professor of lactation physiology. Her area of research is focused on the peripartal physiology of the cows, specifically how calcium homeostasis regulates maternal physiology. Dr. Laura focuses on how the mammary gland controls maternal physiology. She did her PhD at the University of Arizona and the University of Wisconsin Department of Animal and Dairy Sciences. Is very happy to have her as a professor here in our department. She will be talking today of the effects of residual cisternal milk on milk production.
Thank you. And thank you for having me to talk about this really interesting project I did with actually Dr. Doug Reineman, the Associate Dean of Extension in our college. It produced some really cool results. I think it has some applicability to robotic dairy farms and thoughts about how we can manage milk production. So hopefully I can convince you of that. So how the mammary gland controls milk synthesis is through input from the calf or the milking machine that draws demands from her body into milk. So when you make milk, you're going to increase protein demand, and you likely will pull some of that from muscle, if particularly it's not being reached by your diet. And this feeds back to the mammary gland. Similarly, this occurs with energy, and it's why early lactation cows will mobilize some adipose tissue to support milk synthesis, particularly fat. And we also see this with calcium, and this is why cows in this peripartal period have a lot of things to manage, both for herself as well as making milk simultaneously. And this is really driven by the input of the milk synthesis. And why this is important will become relevant to the project we did. And I think some things we really learned about looking at milk yield at a quarter level and really understanding that the mammary gland is individual and that in a cow, there's 4 of them. And so sometimes thinking about milk yield at a whole udder level, we might be missing some things that in a robot we'd be able to capture because of the way the technology works. So if you want to increase milk secretion, there's been a lot of ways to do this, and researchers have been working on this for quite some time. Tom McFadden, who's now at the University of Missouri, along with his graduate student, showed that milking frequency was really important, and they did a lot of different quarter level research using half udder milkers and trying to explore the molecular biology and the physiology occurring there. We know that you increase milking frequency, you increase milk production. We do know too that bovine growth hormone, or BST, can increase milk secretion, and this has to do more with the coordination of metabolism by the cow, but it reliably did so because it was taking more nutrients more efficiently into the mammary gland. We know that this can also be linked to proliferation of the cells. So BST through some IGF-1 interactions can also lead to this production of more mammary epithelial cells. And if there's more mammary epithelial cells, you have more milk production. And this has been shown in a couple of different ways by a couple of different researchers. In my lab, we've shown a lot of this as it relates to serotonin. Prolactin also has a positive impact on milk secretion. And we know that there are several things that can cause apoptosis or cell death. And really the balance of the number of mammary cells there to the number of mammary cells that die is really going to be impactful on milk production. So we know that milking frequency increases milk production, but we also know that if you don't totally remove milk from the udder, you can have negative impacts on this. And so this complete removal of milk is quite critical to the ability of the animal to sustain high-level milk production. The way we manage our farms, we try to set takeoff settings in which the takeoff is set for equally for all 4 quarters, and it comes off, at which point the milk starts to decrease usually from the quarter that is milking the quickest. So it is largely driven by a quarter that I suspect has the most milk and milks really quickly, which may not be representative of all the quarters. So we did a preliminary study here at our farm several years ago, and what we did was we used a quarter milking machine, and we were able to manipulate the amount of milk we were leaving behind in the udder. And in this case, we set quite a high threshold because we wanted to see if there was a long-term impact on the mammary gland and milk synthesis. So we left about 27% milk behind in these quarters. So what our design was that we had 4 quarters. 2 of the quarters were milked completely. So we removed every last drop of milk. There was nothing visible left come out of those quarters. Excuse me. And the other 2 quarters, we calculated the amount of milk that they were being produced, and we would leave approximately 30% behind. And twice a week, we readjusted this because we started these treatments on day 5 in milk, and we continued them through day 47 in milk. And the reason we did that is because we know this is when we're seeing the highest increase in milk production, and we wanted to know what the impact would be, particularly if you weren't milking cows appropriately during that early lactation phase, on her potential long-term milk production. So every twice a week, we adjusted the quarters to ensure that we were leaving that 25 to 30% milk behind. And these cows were milked twice a day, as is standard at our farm. So what you can see here on the left is we have weeks of milk production, and then we have milk production rate that we calculated at the quarter level here. And we actually collapsed it into half udders because we had 2 quarters milked completely and 2 incomplete. And what you can see here is that in these open squares is that there's a reduction in milk production rate in the quarters that we were leaving milk behind in, and we saw what was typical was an increase in milk production in the quarters we were completely milking. Interestingly, the first question we thought was, would you get mastitis if you did this by leaving milk behind? We did see an increase in milk and somatic cell count in these quarters that we did not completely remove the milk from, but because we have a really well-maintained herd and our somatic cell threshold is quite low, none of our cows had mastitis. We did see higher increases, get higher numbers of somatic cells, but still it was well below 100,000 cells per mil. So we have a really quite well-maintained herd. And you can see that this was elevated for the entire period of the experiment. So our thought was, if we were applying this to a robotic herd, you could do a number of things. We could increase milking frequency if we were not removing all the milk, and we're never quite sure how much we're removing. So at least in a herd that has a robot, you could allow for more cows to go in more frequently into the box, and maybe this could overcome the incomplete removal of milk as a possibility. And the other question we had was, is this a permanent effect? So if you were to incompletely remove milk from quarters for 3-4 weeks, can you fix this? Is it a reversible phenomenon? So one thing we know about milking frequency is that this will increase milk yield, and it'll increase lactation persistency over the course of an entire lactation. And this is really independent of nutritional status. So can we recover milk yield when we increase milking frequency in incomplete milked quarters? So we repeated the study that we did previously, but in this case, we had a group of cows that were milked 2x and a group of cows milked 3x. And then within those milking frequency, we had that same incomplete, so 25 to 30% milk left behind and completely milked quarters. And what we saw here in the milk production rate is the black filled circles and squares are the 3x milked cows. And the open circles and squares are the 2x milked cows. So what I can tell you is that that milking frequency didn't correct the effect that we saw with the milk left behind. We just saw an overall increase due to milking frequency. So we couldn't rescue an incomplete milked quarter due to milking frequency. And we saw similar effects on somatic cell that we saw in our previous study. And the take-home message, though, was that milking frequency will increase milk production, but it won't make up for a quarter that is going to continue to have milk left behind. And I do know I qualified that this is an extreme case where we left 25 to 30%, which is a lot. And going forward, what would be interesting would be to look at, what are the thresholds for how much you can leave behind, and how can we adapt this, particularly, like I said, in a robotic system. It might be more difficult than conventional parlors. We took biopsies from these tissues, and what we saw was, in general, in line with previous research, and that was that we saw increases in mammary epithelial cell proliferation, and all of this was related to the milking frequency and not the left behind milk. They just had higher levels of apoptosis. So with 3X milking, nearly all of the genes that were affected, so were all related to cell proliferation. And this was increased in the completely milked quarters compared to the incomplete milk quarters. And we saw decreased expression of these genes in 2X milking cows, and it really didn't matter how much milk we left behind. So in the take home of that is that the actual effect on the capacity of the mammary gland to make milk really is long-term more affected most likely by milking frequency, and not so much how much is left behind, and you can't really correct that response. So I wanted to show you some data here and how this could be applied and useful. So we did a study with Doug Reineman, and data was collected on a farm in Pennsylvania that has a robotic herd. And what you can see here, we have the left front, the left rear, the right front, and the right rear quarters. And the rear quarters both make more milk, and the front quarters make less. But what you can see is that there are differences by quarter, more between the front and the rear, which we know based on the distribution of milk production, but still some differences related to individual quarters. And what this tells us is that if there's a possibility to make adjustments on frequency of the animal entering the box, or completeness settings in which we remove milk, we might be able to overcome some issues related to long-term effects, like on a quarter that maybe isn't making as much and needs to be more readily and completely milked out in order to keep the levels up in production. And so thinking about this gives us a lot of information on what we should do potentially on settings in a robotic system that we just have, because we have more than we would in a conventional system. This shows the averages. So we have quarter milk yield in kilos for the left front, the left rear, and the right rear. Again, this is from the same herd. So what you can see is like those front quarters are less, and they're pretty tight in their averages. And the left rear are also pretty close. And these are an average from days in milk 10 to 300. This is not representative of the average daily yield of these quarters, but it tries to encapsulate all of the yields in an entire lactation. And the rear quarters are making about 1 kilo more. But the ability of the robotic system gives us a lot more capabilities to make adjustments to milk yield. And I think there's a lot of potential to do a lot of research on what we're doing to the udder potentially based on whatever settings we have there that could affect long-term milk yield and also health of the udder too. So this is data from an experiment and why is this additionally important? There are researchers that are looking to reduce milking frequency and complete milk out during the early lactation period, meaning the first week or so postpartum. And the hypothesis is that by doing this, they're reducing the energy inputs to the cow so that she might be healthier and do better through the transition period. What this graph is showing here are the effects of milking management on milk yield during the first week of lactation at the top. And then the bottom graph shows the first weeks of lactation long term. It's a really small study. They only had about 8 or 9 cows, I believe. And what's interesting is, and they had a wrench in here that I can point out, but they have the cows that they milked out completely like normal. And then you can see here, they have quite a bit of reduction. So about 10 kilos per day that they were not removing. And this increased over time for the first 5 days postpartum to keep their energy requirements lower so that they might not have metabolic diseases. And it suggests at least that they didn't have a long-term impact, but it was a relatively short study and a very small sample size. And then they also had a cohort here in the triangles where they left the calves with their cows for a few days and looked at the milk production during that early time period and then followed them out for 9 weeks postpartum. So with people trying to do these sorts of things to maybe improve metabolic function at the onset of lactation, or how they're managing their entry into the boxes on a robotic herd, or how you're setting your settings in a conventional farm, we could potentially be impacting long-term milk yields and also even health of the cow and not even realize it based on what's going on. And as I said, 25 to 30% of milk left behind is quite extreme, but I think we could do more experiments where we're leaving 10 or 15 or 20, and we may not even realize sometimes how much we're leaving behind in a potential quarter that might lead to an issue later on. And I think now that there are ways to look at that. So this is another study that might have implications for this. And this is using a reduction or an incomplete milking in later lactation in order to help cows dry off more gradually. And the solid line is the conventional milked cows and the dotted line are the incomplete milked cows. And you can see that starting around 30 weeks of lactation, they started incompletely removing milk from these cows. And we don't know what this might mean for them going forward, because there are some programming effects on the mammary gland and its ability to produce milk that we just don't understand yet. And so use of these different management styles to help a cow in a metabolic way, or to help her dry off more gradually so that there's less mastitis. We don't know what might the long-term impacts be on milk production yet. And so I think there's a lot of research that could be done in this area. And I really do believe that robotic milkers give us a lot of capabilities, because we have the ability to make settings different at the quarter level that we just don't have in a conventional facility, except for fabricating a individual quarter milker, which is what Dr. Reineman did for me to do that project. So, which is totally not possible in a normal herd.
Dr. Laura,
yes.
a quick question. Is the overall goal of the research to follow the animals across multiple lactations to determine the long-term effect? Is that what you're going to be continuing to do?
That's what we'd like to do. He and I we've talked about it for a long time, trying to design some experiments where we could do this potentially in a robotic system so that we can follow the animals long-term. With the machine that he made me, it was not possible to do so. But that's what we'd really like to do. And we'd have the ability to do this, looking at several different ways in which you would potentially leave milk behind and how that would impact the cow in her next lactation.
All right, thanks.
So I just think that automatic milking systems give us those capabilities, and cows are able to control their own milking frequency. And looking at the interaction of the milking frequency and the completeness of removal, and what that might mean for a cow and her future lactation, and also like potentially on the health of the udder, I think is really important. And so this incomplete milking might be a good thing. It might not, and we just don't have enough data to support it. And so I think there's a lot of research yet to be done in that area. So I'm happy to take any other questions that there might be related to this, but I think robots give us a lot of opportunities to look at a lot of questions we have yet to understand.
I guess specifically, the results on if you have the animal that was incompletely milked out, was the somatic cell tested then to see if that cow, those cows that you left so much milk in, did they have a higher somatic cell?
Yeah, they had elevated somatic cell counts. All of them did, and it was statistically significant. We didn't see any evidence of mastitis, but our cell counts are really low on our farm. So they, I think, got up to like maybe 125,000 cells per mil. So they were really low, but we have really low cell count in our herd. So, but our other ones were like 50,000 cells per mil in the completely milked quarters. So if you're in a herd where you have higher mastitis prevalence, and then you add this on top of it, you could be setting yourself up for more infections.
And did you look at the milk components too? So is the milk left behind towards the end of the milking any higher in fat and protein?
That's a great question. We did look at the milk components. We did see that the cows that were completely milked, they had a higher lactose percent, and we had a lower lactose percentage in the quarters that were where we had milk left behind. The fat and the protein were not statistical, but they were elevated a little bit. So we didn't see like a really pronounced increase in the fat and protein. It was just that the lactose was lower.
All right. Well, that's all the questions that had come through. Is there any more? We'll transition to the next slide there. The Midwest Manure Summit is being held at Lambeau Field on February 28th. Registration is still open, and you can find that on our website. But I would like to take this time to thank Dr. Laura and Dr. Don for your expertise today, and hope everyone can join us again next time.